Welcome to Math with Malia. Today we're going to go over the Eureka Squared Math 7 and 8 Lesson 1 in Module 4. Solutions to linear equations in two variables. This lesson will help us to understand how we can determine if an ordered pair is a solution to an equation. And we're also going to see why writing a linear equation in standard form is useful, what information it can tell us. So first, a definition. What is a solution? Remember, a solution is a value of a variable that makes an equation true. If you plug in that value and substitute it into the equation for the variable, it will make the equation true. Number 1, determine 3 different ways to score 32 points in basketball by using 2-point shots and 3-point shots. Complete the table. So you can pick different values as you like, but they have to add up to a total of 32 points. So when I had my students do this in class, I had some students suggest they could make 1 2-point shot, but they would then make 10 3-point shots. We could also make more 2-point shots, like say 16 2-point shots. That would give us a total of 32, so then they would have to make 0 3-point shots. We could have 10 2-point shots, which would give us a total of 20, so we would need 12 more points. That means we would need to have 4 3-point shots, and so on and so on. You can fill out your table as long as your total adds up to be 32. Number 2, let x represent the number of 2-point shots. So 1x would represent 1 2-point shot. Okay. What expression can we use to represent the number of points scored by 2-point shots? So 1x is worth 2 points. That means there are 2 points per x, or per shot. So we can use the expression 2x to represent all of the points earned by 2-point shots. Whatever number of shots that are 2 points are taken and made, that we will substitute in for x. Multiply that by 2, and that will represent the total amount of points scored by 2-point shots. Number 3, let y represent the number of 3-point shots. So likewise, 1y represents 1 3-point shot, and each 3-point shot is worth 3 points. So then we would use the expression 3x to represent the total, 3y to represent the total number of points scored by 3-point shots. Number 4, the points scored by 2-point shots and the points scored by 3-point shots must have a sum of 32. So how can we write that equation? Well, we're going to combine our two expressions. 2x represents the total number of points for 2-point shots. 3y represents the total number of points of 3-point shots. And I know the total has to equal 32. So if I add my 2-point shots and I add the total amount of 3-point shots, I would have a total of 32. Now, a couple more definitions I want to go over. 32 is a number all by itself. So this is called a constant because it is a number that never changes its value. It is constant. The numbers that are in front of the variables, the 2 and the 3, these change the value of the variable. These are called coefficients. So these are important definitions that you need to remember as we're going through these lessons, because I'll be using these words. So a number in front of the variable is called a coefficient. A number all by itself is called a constant. So here's a table representing our equation. 2x plus 3y equals 32. And these are the values of the 2-point shots, x, and the 3-point shots, y, that would give us a total of 32. Now, what do you notice as we're looking at x, the values of x? What do you notice as we go down the table? each time we move down the table, it is increasing by 3. Okay. And what do you notice about the column for the y values? The 3-point shots. Every time we move down, what pattern do you see? It is decreasing by 2 every time. So we're going to talk about this a little bit later, but notice the pattern as we go down each column. Number 5, use the equation we wrote in problem 4 to complete parts A through C. So verify that the ordered pair 13, 2 is a solution to the equation. Now remember, a solution is a value of a variable that makes the equation true. So how can we determine if 13, 2 is a solution? Well, if we remember how our ordered pairs are written, they are always written x, y. So the x value is 13 and the y value is 2. So I'm going to follow my steps of being a good mathematician, and I'm going to first write what I know. So I know x equals 13 and I know y equals 2. Then I'm going to write the equation. And remember, our equation we had in number 4 was 2x plus 3y equals 32. So I'm going to write the equation I'm going to use. And the next step is I'm going to substitute the values I know into the equation. So let's start with our x values. Let's substitute 13 for x. So as I rewrite my equation, instead of x, I'm going to write 13 in parentheses. And then instead of y, I'm going to substitute the value of 2 into the parentheses. And I know the coefficient is right in front of the variable. That means we multiply. So I'm going to do 2 times 13, which gives me 26. And I'm going to add 3 times 2, which is 6. And let's verify and see if that is true. 26 plus 6 is 32. So yes, the ordered pair 13, 2 is a solution because when I substitute those values into the equation, it makes the equation true. So yes, it is a solution. Okay, so what does this mean in the basketball situation? What does the 13 represent? What does the 2 represent? Well, we know that the 13 represents the x coordinate, and we know that the x coordinates, or the x values in our problem, were the number of 2-point shots. So that means they scored 13 2-point shots for a total of 26 points. And the 2 we know represents the y coordinate, and we know the y values in our equation represented the 3-point shots. So that means that they made 2 3-point shots for a total of 6 points. Part C, we have another ordered pair. To determine if it is a solution, we're going to follow the same steps. Let's label what we know. So I know x equals 11, and I know y equals 3. We're going to write the equation that we're going to use. 2x plus 3y equals 32. And then we're going to substitute the values that we know into our equation. So instead of x, I'm going to substitute 11. And instead of y, I'm going to substitute 3. And we're going to verify and see if this makes the equation true. 2 times 11 is 22. 3 times 3 is 9. 22 plus 9 is 31. That does not equal 32. So that tells us that 11, 3 is not a solution because it does not make the equation true when we plug in those values into the equation. So remember to follow these steps when you're doing your math: to write what you know, to write the equation that you're going to use, then you substitute the values that you know into the equation, and then you calculate. Step 4 is to actually calculate and do the math. All right, we have here a grid with a bunch of dots on all of the ordered pairs. And what we want to look at are some patterns. with linear equations. So which ordered pairs would give us a sum of 5? And you can just pick some. So if I say my x value is 1, then my y value would have to be 4. That would give me a sum of 5. If I had an x value of 3 and a y value of 2, that would also give me a sum of 5. If I had an x value of 6, I would need a y value of -1 to give me a sum of 5. If I had a x value of 5, then I would have a y value of 0 to make the sum 5. Let's do one more. If my x value was 8, I would need a y value of -3 to have a sum of 5. Now, what do you notice with those points? If we were to connect those points that all had a sum of 5, they would form a straight line. So we can see we're working towards identifying patterns in a linear equation because all of those points on that line would all have the same sum. They would all have a sum of 5. Okay, here we have some more equations, and you can see that they're all written in the same pattern. We have the x term first, and then the y term, and both the x term and the y term are on the left side of the equal sign. So both the x terms and the y terms are on the left side of the equal sign. And on the right side of the equation, we have numbers that are all by themselves or constants. When an equation is written in this form, it's called standard form. Okay, sometimes the variables will have coefficients in front of them, and that's represented by the capital A and the capital B, and the capital C stands for constant. This was how our equation was written at the beginning. Here's our equation right here that we were working with. So number 6, we have a new equation, and we can see that yes, it is written in standard form. We have our x values and our y values on the left side of the equation and our constant on the right. We want to find 4 more solutions for this equation. And we can see that they've given us a value for x and they've given us a value for 2, and the rest are left blank. We're going to determine what those are. So when the value for x is -1, we've already practiced this. We know x is -1. Let's plug that into our equation and substitute. So instead of x, I'm going to substitute -1, and I'm going to write the rest of the equation. We can practice doing our property of equality or opposite operations to solve. So 2 times -1 is -2, minus y equals 8. I'm going to do one step and then write everything else. I need to move the -2 to the opposite side, so I'm going to add 2 to each side. That leaves me with -y equals 10. Now -y, there is an invisible 1, so really I need to divide both sides by -1 to solve for y. That means y equals -10. So by substituting our known value of x, we can use the property of equality, opposite operations, and find the value of y that would make the equation true. Okay, when our value for y is 2, we're going to do the same process. We're going to substitute 2 into our equation. So let me draw a line here so we have some clear room. Okay, so 2x, I don't know x, we're going to solve for that. Minus, now instead of y, I'm going to fill in the variable I know, equals 8. And we're going to do the same process, opposite operations to solve for x. So let's add 2 to both sides. That leaves me with 2x equals 10. Divide by the coefficient, divide by the coefficient, x equals 5. So when y equals 2, in order to make the equation true, x needs to be 5. So you could keep practicing this by picking a value for x and a value for y, substituting into the equation, practicing your opposite operations, and solve for the missing variable. Okay, then we would graph it. So let's do one more point so we can have 3 points to graph. Let's say our x value is 6. Okay, so we're going to do one more. I'll draw one more line to separate these problems. So instead of x, I'm going to substitute 6. Okay, we're going to subtract 12 from both sides. Leaves us negative y equals, actually, I'm going to show you another trick. Let me show you another trick, because sometimes I don't like to have a negative variable. So I'm actually going to move the 8 over here, and then I'm going to move the y to the other side. So if you get confused, I'm doing 2 steps in one. I like to draw arrows to show where I'm going to move my term. So I'm going to move the negative y over to that side. That means my other arrow needs to go in the opposite direction. So I'm going to move my 8 to the left. Okay, so that's what I've done by doing the opposite operations. And then we can see we'll have a positive y value. 12 minus 8 is 4. That gives us a positive y. Okay, then we didn't have to forget to divide by negative 1, or we wouldn't forget. So when x is 6, to make this equation true, y has to be 4. So we've got these 3 points that we can graph on the coordinate plane on the next page. All right, the points here again, so we can remember negative 1 comma negative 10. And we have 5 comma 2. And then we're going to plot 6 comma 4. Okay, and remember, we always run before we jump when we're graphing, when we're plotting ordered pairs. So negative 1, we're going to go to the left, and then down to negative 10. There's our first point. Then we're going to go to the right 5 and up 2 for our second point. And the last one, we're going to go right 6 and then up 4. Okay, we have 3 points. It's good enough for now. And if we connect these with a protractor using nice, straight, accurate tools, we can see that those points will be in a straight line. They form a straight line. They all have the same sum. Okay, we've got one more table to complete. We have a new equation. Notice there is a fraction as a coefficient for the x value. We'll need to be careful when we do our math calculations to find the missing variable. Since the denominator is 5, it would be good to choose values for x that are multiples of 5, because then we can simplify really easily. So I'm just going to stick with values for x to choose that are multiples of 5. So let's do negative 5, 0, and positive 5. And we're going to follow the same steps. We're going to substitute into our equation our known value of x. So instead of x, I'm going to substitute negative 10 plus y equals 3. Okay, and I know that 5 and negative 10 can simplify. This would become negative 2. So 2 times negative 2 is negative 4 plus y equals 3. I would add 4 to both sides. Y equals 7. Let's do the next one. We're going to substitute negative 5. So instead of x, we're going to substitute negative 5 into our equation, and then we're going to do our operations to solve for y. So negative 5 divided by 5, that cancels out and leaves us with negative 1. So 2 times negative 1 is negative 2 plus y equals 3. I would add 2 to both sides. Y equals 5. And we're going to substitute 0 for x, and I chose this one on purpose, and you'll see why. It's very easy. Okay, 0 times anything is 0, so that just leaves us with y equals 3. And the last one, we'll substitute positive 5 into our equation. 5 divided by 5 is 1, so that leaves us with 2 times 1, which is 2, plus y equals 3. I need to subtract my constant from both sides, so y equals positive 1. So here we have 4 more points to graph on our coordinate plane. Now, what should we expect to see when we plot these 4 points? We should expect them to all be on the same line. If they are all solutions to the same equation, they should form a straight line. So here are our points. And I just need to graph one more. Negative 10. Oh, it's not negative 1. It's 7. I don't know why I wrote negative 1. Negative 10, comma 7. Okay, so there are the 4 points that we graphed. Remember, you run before you jump. And if we connect those with our protractor or a ruler to make a nice straight line, making your line go all the way through the coordinate plane and adding arrows onto the end, we can see that yes, those points all lie on the same line. That means they are all solutions to the same equation. So how do we know whether an ordered pair is a solution to an equation? Well, remember, we substituted the values of the ordered pair, the x value and the y value. We substitute that into the equation. We do the math and we see if it makes the equation true. If it does make the equation true, then we know that that ordered pair is a solution. If we do not know whether the x value or the y value are, then can we still find a solution? If we know one of them, we can choose a value and substitute it into the equation and find the missing value, just like we did in the table, in the 2 tables in number 7. We chose values for x, we substitute them into the equation, and we found the y values that would make the equation true. How many solutions are there to a linear equation in the form of ax plus by equals c? Well, I'm going to flip back to our line. We plotted 4, but could I also talk about any other point on that line? Any other point on this line would be a solution to that same equation. So there are an infinite number of points on this line that I could choose, and that x value and that y value would be a solution to that same equation. Well, thanks for doing math with me today. I hope this helps. Remember, you can be good at math. I'll see you soon. Happy mathing.